In this video, I'm presenting our WACV23 paper, where in a nutshell we compare 3D CNNs, video transformers, and recurrent models on how well they generalize in video tasks with domain shift. We extended the notions of shape and texture bias from this ICLR19 article to video models and presented two public datasets to investigate domain shift and temporal modeling. One of those datasets is the Temporal Shape dataset, which is a task of trajectory classification where one frame doesn't matter. We have 5 classes across 4 domains, and what we do throughout the paper is to train and validate within one domain and then take the best model and see how well it performs on the other ones. When we train on 2.0, we found that the green and blue curves, Convolve and the transformer, are the most flat and thus the most robust across the domains. And when we train on NIST with background, it's the larger transformer that's the most robust. These are our modified domains of diving 48. We have the 2 shape domains, S1 and S2, where we've segmented out the class evidence, and then we have T, where we only see the background and not the class evidence, which we call the texture domain. And we'll still study here how the models drop on unseen domains, and the models are always trained on the original data. Here are examples of results where all 3 models have the same number of layers and units, and they also have the same exact performance on the validation domain. And what we see then is that the blue and red 3D CNN and transformer actually increase their results on the texture domain compared to S1 and S2. Whereas the Convolve always drops in the texture domain. Another example experiment here is with the best versions of the models after hyperparameter search, where we see that the 2 models drop similarly for S1 and S2, but that there's an important gap here between the 3D CNN and the Convolve on the texture domain. We also looked at some qualitative examples here. And to prepare for this, we can note that every class in diving 48 has 4 attributes, which is about how the diver starts, so the takeoff, how many somersaults they do in the air, whether they twist or not, and what their flight position is. So every class is defined according to these 4 attributes. And when we looked at the misclassifications on random clips and classes, we found that among the misclassifications, the Convolve for every random class we looked at had the most correct attributes. So it looks like the Convolve focuses on more relevant patterns for the task. And what we saw in this study were indications that recurrence for temporal modeling helps with cross-domain robustness, and that the Convolve exhibited less texture bias than the 3D CNN and the transformer. And what we draw from this is that temporal modeling in the base architecture can matter for high-level behavior, and that there's a point to revisiting the fundamental architectures of the models rather than adding advanced superstructures or sophisticated training schemes to models to cure their symptoms. How to model frame dependency in video is an important question. And we recommend research in action recognition to evaluate models with more domain shift to be reminded of these remaining issues.